So we've looked at parabolas and we've looked at circles. So now we're going to look at the third type of conic section. Remember, those were the parts that were cut of two cones point to point. And these are called ellipses. Um, Everybody knows what an oval is, and that's kind of what an ellipse is. Really all it is that if we have a center of it, there are 2 points that are called the foci. They're actually the focus points. And they're a certain distance away from the center of the ellipse. And if you were to think of, okay, let's say it's that far away. If I were to take and put a string on here, like that, of some length, and then I take my pencil and I pull that string tight, and I just start, I'll do it this way, pull that string tight so that it's out like this from those 2 points. So my pencil's right there pulling on that. And I just kind of slide it around. What ends up happening is because this is a fixed length, this string is only a certain length, I'm just moving it along so that now all of a sudden, instead of coming up here like that, it comes over to here and then down, and then down to that point, and my pencil's over here now. And I keep going around, and what it does is it creates a thing that looks like this. And what that is that's called an ellipse. All it is that any point on this ellipse, any single point that I have, if I were to add together the distance to this focus point and to this focus point, that distance is the same as this distance is here, forever as this distance is right here together for any point on that ellipse. And just like the equation of a circle, ellipses have a standard equation. And if the ellipse, as the long way of it is this way, the long direction of the ellipse is called the major axis. This short distance, shorter length right here is called the minor axis. Now that can go either direction. It can go this way in the x direction, or it can go, not very good at drawing these. It can go like that in the y direction. So this would be the major axis, and this would be the minor axis. Okay, so we have two different things. The equations of these are related, but they're different. And so all it really is this is x squared over a squared plus y squared over b squared equals 1. Where this length a right here is the distance from here to here. That's a right there. Okay, not a squared. This is the square of it. So to find what a is, we have to take the square root of that. B is the distance from along the minor axis, so b is this distance right here. Okay, so we take the square root of that, and that finds us what that length is right there. Okay, the centers on all of these that we're going to look at are at 0, 0. It doesn't change it a whole lot if they're somewhere else, but that's what we're going to do. For one this way, because the major axis runs this way, this length right here is a, and this length right here is b. Notice that a is in the y direction, so that changes the equation and just makes it x squared over b squared plus y squared over a squared equals 1. And all you really have to know is that for both of these, a squared is the bigger number, a squared over b squared. So whichever one of these is the bigger number, whatever variable that's under, that's the direction the major axis runs. The minor axis runs the other direction. And so let's take a look at some examples like your homework's going to be. So we want to identify the center, vertices, covertices, length of the major axis, and length of the minor axis. So we want the center, the vertices, the covertices, the major axis, and the minor. Major and minor axis. Okay, so we're going to find 5 things for each one of these. Well, the first one's really easy on all of them because it's 0, 0. And so we can look at this because this is the bigger number and it's under y. I know that the major axis runs this way. Okay? The center is at 0, 0. And so a, this is a squared, and this is b squared. So a is going to be the square root of that. A is going to equal 12. B is going to be the square root of 36, so b is going to equal 6. The vertices, because I'm moving in this direction, I'm going up and down from 0, 0. So if I go up 12, one of the vertices is going to be 0, 12. If I go down 12, it's 0, negative 12. It's the y that changes along the major axis in this case. The covertices are in the x direction. B is 6, so from 0, 0, I'm going to go 6 this way, which would be 6, 0, and 6 the other way, which is negative 6, 0. What that does then is the length of the major axis, it goes from 12 up above to negative 12 below. That's a total length of 24. That's just 2 times whatever a is. The minor axis has a length of twice this. So the minor axis has a length of 12. Okay? So let's jump down here. Let's look at another one. Let's look at number 3 down here. We know that bigger number is a, so this is a squared, this is b squared. I know that it runs, the major axis runs in the x direction. The minor axis runs in the y direction. And so we want the center, well, 0, 0, that's easy. We want the vertices, the covertices, the major axis, and the minor axis. So a squared is 196, so a is going to be 14, square root of 196. I'm going to go 14 in this direction from 0, 0. So if I go 14 this way from that, that's going to be 14, 0. If I go 14 the other way, it's going to be negative 14, 0. That has a total length then of 2 times 14, or 28. The covertices, this is b squared, so b is going to be the square root of 64, which is 8. I'm going to go 8 up or down to find what y is for the covertices. So if I go up 8 from this, that's the point 0, 8. Down 8 is 0, negative 8. The minor axis has a length of 2 times 8, or 16. And that's what your assignment is today, is just finding the parts. Let me know if you have questions.